Okay, so let's just talk a little bit about solving quadratic equations. So who can tell me how we would solve this? Add 2 to both sides, and I would get 3x equals 9, divide by 3, x equals 3. Thank you. What will we be able to solve when we do this? What looks different with this one compared to this one? Has a squared. So does anybody remember the form that this equation is in? Good job. That's tying things together. That's what I'm looking for. Y equals mx plus b. That's a straight line. And what's this one? Y equals ax squared plus bx plus c. It's in the form of a quadratic equation, but not quite. What could we do to this equation so it looks more like the standard one? Good. I could subtract 7 from both sides, correct? If I were to do that, I would get x squared plus 6x minus 7 equals, we usually put a 0 and we don't see anything else on that other side. Now does that look a little bit more like that? Where a equals what? 1, and b equals 6, and c equals -7. And we can do things and manipulate these numbers right here and find axis of symmetry. What else can we find? Vertex. Then we can start plotting points, right? And we could graph it. Okay. So this would be a graph of this equation that we just transformed. This is a graph right here. I know my axis of symmetry. I know my vertex. Is this a maximum or a minimum? It's a minimum. Good. There's just one thing that we haven't discussed yet. We haven't discussed the solutions of this graph. That's what we're going to do today. Find the solutions to this graph. So this way, besides graphing, what else could we do with a quadratic equation? In what form? What would you put it in? It already is. It's in that form. Does this look familiar to anybody?
Could we plug the points back into the equation?
We could. That's how we graphed it. Forget what we've been doing this week. Think back to what we have done before with a quadratic equation. What could we do with this? The box. Good job. What is it we're doing when we use the box? I think I heard it. We're factoring. Let's factor this. So I'm going to use the box. No. You don't need to write this down. I just want you paying attention. Where does x squared go? In the first box. Where does -7 go? Lower right-hand corner. If I don't know how to find these two values here, I can use an x. This is the attic, a times c, -7x squared. Here's the basement, 6x. What two numbers? When I multiply, I get -7x squared, and when I add, I get 6x. How about 7x and -x? Does that work? So 7x and -x would be right here. Okay, so help me factor this. X and x, good. What goes here? -1 in here? 7. So if I were to factor this equation, it would be, put this up a little bit, x minus 1, and x plus 7. So this is a representation of the quadratic equation. This is also a representation. Can you see where it's represented?
No.
Here's a clue. Anybody see it? I have x minus 1 and x plus 7. That's in this graph somewhere. Where? But it's not negative. The solutions to this graph are 0, negative 7, and 0, positive 1. Those are the two solutions to this graph. But where did I find that?
Right?
Exactly. Not just the opposite, though. I'm basically saying that x minus 1 times x plus 7 equals 0. So each one of these is equal to 0. Right? Because if I had a times b equals 0, don't they both? Right? So when I add 1 to both sides, I get x equals 1. And when I subtract 7 from both sides, I get x equals negative 7. Isn't that what I have here? So what we originally did with factoring, now normally the book tells you to factor and then set it up to 0 and solve for x. Well, if I would have had you do that a month ago, you would have not known why you're doing that, right? But what you're doing is you're taking and you're solving a quadratic equation of where the graph crosses the x-axis. Okay, I know that's a lot to take in. Let's talk about it for a second. So, how far the ball is traveling. The x-intercepts of a parabola are called the roots or the zeros, and this is why. If you're standing right here, the ball, if it's on the ground before you hit it, the ball is at 0 elevation, right? As long as you're on the ground, right? As long as you're not down in the sand pit, the ball is on the ground at 0. Then you hit the ball and it goes high up in the air to its maximum height, right? Then it slowly comes down and it lands back where y equals 0 on the ground, right? That's why we call these zeros. They're zeros because the ball is not up in the air and it's not down below. It's right on the x-axis. So has anybody seen that video called Golden Tee? No, it's like in a Dave & Buster's or whatever, and you like spin the wheel and it makes the ball go up in the air and then it makes the ball, it's a golfing game. How do you think that video game works? Right? They're using y equals ax squared plus bx plus c. Whatever effort you give on that ball, it's going up in the air and it's landing, and this is the solution to the problem, is where it lands. Okay. So let's talk some vocabulary again. I'm actually going to make this a little bit easier on myself. So, is this maximum or minimum? Minimum. Is this one maximum or minimum? Maximum. Is this one maximum or minimum? Max. Is this one maximum or minimum? Minimum. What are the roots of this parabola? 2, or I could say 0, sorry, it would be 2, 0, where x is 2 and y is 0. And the other root would be -2, 0. What are the roots for number 2? -2, 0, and +4, 0. What about the roots for number 3? I'd say more like 1 and 1.8 would work. 1 3/4 and 0. I mean, we're not exact, but it's pretty right on, right? And -1 3/4, 0. And the last one? What are the roots? 1, 2, 3. -3, 0. Can anybody tell me when this would occur when I'm factoring an equation? When would I only have one root? Let me ask it a different way. What would it look like? X, what? Would it be -3 or +3? Plus. Right? Because when you set it up to 0, you'd have to subtract 3 from both sides. That's why it's always switched. So if it's -3, it means that when it's factored, in factored form, it would look like that. So if it looks like that, when do we have an equation that we factored, ax² plus bx plus c, and we only have one root? Don't we normally have 2? Can you see it yet?
Yeah.
Squared. You're welcome. Good job. Wouldn't it look like this? Or that? So when we factor something and it turns out to be a perfect square trinomial, it means it only has one root. And we call it a double root. And we call it a double root because it serves to, there's two roots there, but they're at the same point, right? Okay. Now we can start, now I want you guys to start taking notes. We're going to do these together. So just to kind of get an idea of this, and because I already have a heads up and can already look at this and say, I can see a lot easier way of doing this. Let's factor it first before we graph it. So do I normally use the y? Not usually. So let's just say x² minus 9 equals 0. Anybody notice anything about x² minus 9 equals 0? It's not a perfect. It's the difference of two squares, where x times x makes x², 3 times 3 makes 9, and I'm going to say it's a positive and a negative because they're going to cancel each other out. Well, we just talked about this, right? Aren't these the solutions to my graph? So x plus 3 equals 0 is a solution, and x minus 3 equals 0 is a solution. So x equals -3 and x equals 3. 1, 2, 3. 1, 2, 3. There's where my parabola is going to cross the x-axis. I didn't just find that, though. What else did I find right now?
Axis of Symmetry.
I just found the axis of symmetry. How did I do that? I didn't do any work. How did I do that?
You just did it.
How? Not just because I put a line down the middle. How do I know that's the axis of symmetry? It's in the middle of the two. I know that quadratics are symmetrical. So if I go over 3 and I can go over 3 this way, that means my axis of symmetry must be right there in the middle. I also found half of the vertex already. So I don't have to go over on the x-axis or over on the x-axis. I know the beginning of my vertex is 0. So I was just able to fill in the axis of symmetry, 2 points of my graph, and start my vertex just by knowing that x squared minus 9 equals x plus 3 times x minus 3. Do you see how I mean? If you've been doing what you were supposed to be doing, all of this comes together? It should make sense. All right, so let's finish it off. I don't even need to do the axis of symmetry, so I don't need to fill this stuff in at all. But I am going to only need, now the first day I said you needed 4 shells, the second day I told you you needed 3. Today you're going to only need 2. Only 2 more. If you do the factoring first, I only need 2 more. Why do I only need 2 more? You only need 5 points to really graph a parabola correctly. I already know which way it's going, though. I know it's going up, so I just need to know how to make the loop. And I only need one side of it because I already know where the other side's going to be because I already have the axis of symmetry. So let's plug it in. We've got y squared equals x squared minus 9. I'm going to write 2 shells. And that's all I'm going to need. Oh, sorry. I don't know why I did that. So what am I going to put in first? 0. If I plug in 0, what do I get? Negative 9. I just found my vertex. And negative 9 is actually right down there.
So why do you... Yeah, so we're done.
No, we need 1 more point. To make a proper parabola, we need 1 more. Well, 2 more, but we really only need to find 1 more. So tell me, what do you want me to find? Just do 1? So if I put in 1, what do I get? Negative 8. So over 1, down 8, so I just found that one. And I just found if I went to in the negative direction 1, I would also get negative 8. So that would be this one. And I have my parabola. And I can see how factoring an equation relates to the roots of my equation. Let's try another one. Write this one down. Okay, so your choice. Which one do you want me to start first? You want me to factor it first? Or graph it first? Yeah, let's factor it because there could be some stuff that when we factor it, we could use instead of graphing. All right, so is everybody okay with me just putting the 4 on the other side? I just have to add 4 to both sides, right, to get it over there? So x squared plus 4x plus 4 equals 0.
Once you find that out, you can do that to axis of symmetry.
So this is my a times b, so that's 4x squared. And this is b, that's 4x. What 2 numbers make 2x and 2x. I'm seeing a pattern. What goes here? X and x. What goes here? And what goes here? So this is a perfect square trinomial, which means there's going to be how many roots? 1. It's a double root. So not only did I just find from factoring first of all, it's not going to be at 2, it's going to be at what? -2. Because when I solve for it, x plus 2 equals 0, I'm going to get -2. Factoring becomes even more of your friend when I also tell you, you just also found the vertex. Right? You found the vertex because that's the very bottom of the graph. It's touching, it's going down, it just touches the x-axis and it goes back up. Isn't that the vertex right there? So this is -2, 0. That's one of my points, -2, 0. And I also just found what? The axis of symmetry. Correct? All by factoring it first. That's fine. The other way is easier, that's fine. All I want you guys to do is relate this to this. Okay? How they relate. How they both interact with each other. They are not two separate things. They're the same thing. Okay, so now that I know that, all I need to do is pick a couple more points, right? In fact, I only need to pick exactly 2 more. So y equals something squared plus 4 times something plus 4. I'm going to put 2 shells here. What do you guys want to plug in? 1. When I plug in 1, what do I get? I get 1 times 1 is 1. I got 4 times 1 is 4. Plus 4, I get 9. If I plug in 1, I get 9. Over 1, 1, 2, 3, sorry. Over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that there's another point. How far away? 1, 2. I had to go over 3 away from the axis of symmetry. So I need to go over 3 this way from the axis of symmetry. I only need 1 more point. What am I going to put in? 0 would be a good one, right? Somewhere on this axis, I'm guessing probably right around here. So if I put in 0, what do I get? I get 4. Put in 0, I get 4. 0, 1, 2, 3, 4. It's 2 distances away from the axis of symmetry, so I'm going to go 2 distance away this way. That's my parabola right there. And we're done. Oh, I have one more thing to show you. It's easy, don't worry. Just kind of like a summarize. I just want to make sure everybody's got this down. Okay, pencils down. What does 2 solutions look like? It hits the x-axis twice. That means it comes down and it goes back up. Couldn't it also be in the negative direction? I wonder if I can just flip this around. Oh, I can. Right? What does 1 solution look like, or a double root? It hits at 1. Or the other way. Now I just messed with it too much. We'll leave it the other way it was. What does no solution look like?
actually one.
No, it's still parabola.
It's not on the x-axis.
It never touches it. So when you're factoring and you get a no solution where it's not factorable, it's a prime factorization, that means that it never touches the x-axis. That's what that means. Any questions? No? Okay.